Okay, so in this screencast, we're going to talk about constrained and unconstrained optimization and using the cigars and brandies example. So the unconstrained problem first, then the constrained problem. We'll also do a little bit of visualization of what's going on. So the unconstrained problem was this. Wally consumes cigars and brandy of an evening. His utility function looks like this. Utility of the two variables is 20 times cigars minus cigars squared plus 18 times the number of brandies he consumes minus 3 times that same number squared. And we're going to solve the unconstrained problem first. Unconstrained because there's no limits placed on the values that C and B can take here. Okay, so we'll go to the unconstrained sheet and see how we set up Solver to do this. Okay, so first of all, we've got choice variables, cigars and brandies, and we've got an objective function, utility. The key here is that we've named each one of these cells. Cigars is named C underscore, brandies is named B, the quantity here. Utility is a function of those things. So utility is 20 times C minus C squared plus 18 times B minus 3 times B squared. Okay, let's go to the solver window. So at solver, what we're going to do is we're going to maximize the objective function, maximize utility by changing variable cells B3 and B4. Now, if I wanted to put this in again, I can go like this, very simply. Or if they were non-contiguous, what I would do is I'd click on B3 first, I hit a comma, then a control key, and then click on B4. In any case, I can solve the problem, and it says, okay, here's a solution. We can check to see that this is a good solution by moving around a little bit, okay? And then we'll soon get visual confirmation. Let's go back to 10 here. Maybe 2.9 might be a good way to go. No. Solve it again, and we're back to our solution. By the way, of course, the exact solution is 10 and 3, and the maximized value of the objective function is 127. Solver doesn't exactly get the exact solution. It stops when it's close enough. Okay, but for our purposes, this is good. All right, so let me show you some pictures here. Here's a picture of the utility function. The Z direction is utility, and the X and Y directions, those are quantity of cigars and brandies. I forget which is which here. Well, we can figure that out because we've got here cigars going up to 20. So cigars is this axis, and the other axis going up to 8 is brandies. How do we construct this? Well, we did this. We first of all named a range. Well, actually, we named two ranges. The blue range there is cigars. The red range is brandies. That's opposite to the color coding we used when we created it. But you can see that this is a function of 20 times cigars minus cigars squared, etc. And how do we know which value of cigars to use? Well, if we are in this row here, we're going to use 5 for cigars because that's the row we're in, row 9, and 3 for brandies, and that's because we're in column K, and you can see that. Okay, so how do you then create the graph to the right here? Well, having done this, what I can do is select the entire range, which is the values of utility in the interior, the values of cigars and brandies on the exterior left-hand column, top row, with a blank over here in the left-hand corner. Go to Insert and go to Charts. And the chart I want isn't showing up. I need a surface chart. Where is that going to be? So the surface chart, I go to All Charts and Surface. And this is what it's going to look like. Hit OK here. Now it turns out if you right click on this, we can do various things. One of them is 3D rotation. How does that work? Well, we can rotate the X values like this. We could rotate the Y values, do various stuff, and eventually get it looking kind of nice. And we can change the perspective a little bit. Okay, enough of that. Now, by the way, we could have done this with a table, and I've got a table solution. The only problem with this one is that we can't graph it because we got this pesky thing in the upper left-hand corner. The upper left-hand corner to do a 3D surface graph like the one we've got has got to be blank here. Okay, the table, we're simply tracking the value of utility, B6, all right, as we vary, and looking at the table, B4 and B3, right? Okay, so that's a two variable data table. Constrained. Well, let's go back to our documentation. Wally's doctor's concerned. Yeah, there's a persistent cough, and he says, the doctor, he or she says, cut back on your consumption of cigars and brandies. Each are equally bad. Just do not consume more than 5 cigars and brandies in a given evening. All right, so what's Wally's optimal bundle given that he has to conform to this constraint? Well, let's go to the constraint sheet and explain what's going on here. Okay, so that we've set this up, the key thing we've done is we've added these 2 cells. All right, so the first cell is doctor's orders. That's what the limit, 6 in this case, right? Well, we can make the limit 5. The second is a cell which registers whether or not we've met the constraint. Well, check it out. We've got 10 cigars, 3 brandies. That's 13 total, and doctor's orders is 5, so we're 8 off from the constraint. How does that work? Well, we take the constraint, which is cell B8, the doctor's orders, subtract the total amount of cigars and brandies. We find we're off by 8, -8. We are not meeting the constraint. We got to get it back to 0. Okay, so let's check out what solver does. All right, so solver, going to, once again, to data, solver has got the same setup up top. We're trying to maximize utility, which is in B6, by changing B3 and B4, which is cigars and brandies. But there's a constraint. The constraint reads like this. B9 has got to be greater than or equal to 0. What's B9? Constraint met. B9 currently is -8. As noted before, we're way over the constraint. In this case, the constraint met is a negative number. The way we set it up, we could have set it up opposite to that. If we had C plus B minus the constraint, we've got, however, here a negative number. We've got to get back up to 0 at least. That's the constraint. And the way we can do this is, well, first of all, let me show you how to add a constraint. Let me take this one, delete it. Add is simple. Okay, so I go to cell reference, this guy, change it to greater than or equal to, make it 0. And you can see this is fairly flexible. There are lots of possibilities I could have here. You're going to use a binary constraint in the homework. Okay, so here we go. Hit OK. Solve it. All right, so now the solution says that this is the correct solution, right? So the constraint is indeed met. We're at -4 times 10 to the -11, so that's essentially 0. 4 cigars, 1 brandy, utility 79, and we are meeting doctor's orders. 4 plus 1 is indeed less than or equal to 5. Great. Okay. Oh, by the way, so here's a graph. What's going on in the graph? Well, to see what's going on in the graph, first of all, let's change the constraint to, say, 12. All right. So now we've got a much bigger surface here. All right. And notice it's cut off. How's it cut off? Well, you can see it visually here. You can also, and by the way, I could rotate this, do that 3D rotation thing, and go with the X rotation here, and just take a look at this thing, and see that it's basically utility surface, but some of it's cut off. Okay, so let's go back to where we were. There we go. Okay. What's going on? Well, this is a 3-dimensional table, all right, but there's a little bit difference here. Let's check out, first of all, there's this ridge right here. What's along the ridge? Well, that's where the constraint is being met. 11 plus 1 is 12. 10 plus 2 is 12, etc., etc. 4 plus 8 is 12. We're meeting the constraint everywhere. Here, remember, the constraint is 12. All right. So we're displaying the various possibilities here, okay? And notice that if this is the situation, we'd probably want to go to here. That's the optimal value. We can check that. All right, so let's go to solver, solve this thing, and it says 9.25, 2.75. Well, pretty close. 9.25 and 2.75. It's pretty close to 126 here. We were about right, and that's over here. We move over here, okay? All right, so what's the formula here? Well, let's double click in here. Cigars plus brandies less than or equal to constraint. If that's the case, then we've got our utility value. 20 times cigars minus cigars squared, etc. Otherwise, if we don't meet the constraint, then give me a blank. That's what this thing is doing. Okay? All right, so that's a visual description of what constrained optimization does. So that's enough for now.